All right. Welcome to another IAEI News Live. My name's Thomas Dimitrovich, and yes, we're live. So, I hope everybody is ready for a discussion. I'm not going to say it's a great discussion. I'm just going to say it's going to be a discussion. So, we're talking maintenance today, and I'll let you know what started our discussion once we get going. But we're going to talk about maintenance of these devices, receptacles, maintenance of receptacles based on NFPA 70B and any other reference that we could possibly muster up. And it all starts now. Okay. All right. So let's get the chat up here. David Engelhardt, Eastern Time Zone afternoon to you too. Seems like we'll be taking a deep dive into chapter 24 of 70B. And I got to get my phone out of the way. Look at that. That thing was in the way. I keep my phone right there so I can keep track of who's trying to yell at me. Felix Sandoval, good to see you this morning. And Mr. Froming in the house, he is always ready. That's one thing I know about Steve Froming. You know, I said this about Tom Lichtenstein, but he may be late, but he's worth the wait. And Steve is early, probably on your tractor. All right, I don't know about you, Steve, but it has been raining here. Been terrible. Fred B, how's it going, buddy? Hope all is well with you. All right, so I want to talk about, oh, can't show that one there. Let's get that out of there. I need to get man, where's my stuff? So what I want to talk about are okay, let me tell you what happened and what prompted I was going to have a different discussion today, but I decided, in fact, I wasn't supposed to be here today. If you recall, I was supposed to be in an event here in Pittsburgh, but I don't have to go till later this afternoon. So we have a meet and greet tonight. I thought that I was going to have to be at an event, part of the event this afternoon starting at 12, but I didn't pay for it. So I can't go to the pre-event presentation. So you're stuck with me live. All right, so here's what happened. I got a call. So first of all, before I go to what happened on Sunday, rewind back to last week. Last week, I was at an event where we had basically some, like a panel board, we had a receptacle, and we had some individuals who are not electricians, and we just wanted to say, look, this is what our industry does. And we gave them a brief overview on what we wanted them to do and install a receptacle and a circuit breaker and some wire and all this good stuff and just do some terminations. And then we were going to have some fun. We were going to check it, make sure it all looks good, and then we're going to energize. And basically there was a receptacle with a hairdryer on it and a light, just like a little lamp. So like a light bulb on the board. So it's it was a no-brainer. We had like 4 stations set up, and And it was fun. Everybody, they had fun, playing with receptacles and landing the terminations. We had some really good discussion on where the hot goes, where the neutral goes, where the ground goes, and all the details around grounding and bonding. These are electrical people. They're not somebody who don't have a general understanding. They're just not wiremen. They're not electricians in the field. So we after we did each of the stations, everybody got done. We looked at all the installations, made sure that there wasn't any blatant errors that were going to cause us some issues. We have GFCI breakers in there, so we know, and the fault currents are low. So everything was good in a controlled environment. So we go to the first one, energize it, the hairdryer turns on, the light turns on, everybody's happy, high-fiving, go to the next one. Same thing, hairdryer turns on, the light bulb turns on, everybody's happy. Third one, same way. Third one. The fourth one was fine. The third one, we couldn't get the light to turn on. We couldn't get the receptacle, the hairdryer to turn on. Light turned on, so we knew we were energized. But the hairdryer wouldn't turn on. So we said, okay, hold on. Let's take a break. Let's look at it. Turned everything off. Looked at the wiring. The wiring was fine. Now, the way this works was we had a receptacle. We had two receptacles. So we plugged the lamp into the second receptacle, turned the circuit on, and the lamp turns on, or the hairdryer. The hairdryer turns on. And then plug it into the other receptacle, and one receptacle is feeding another receptacle. So we're like, what the heck? So all said and done, what happened was these things here have a tab. Okay? There is a tab in between these two. And the tab is on both sides. Okay, so that tab is there to separate the top from the bottom receptacle. So we weren't supposed to have one of those in this lab exercise. So somebody, hey, Steve Cavaleras, somebody was having fun. All right, let's just say that. So the tab was broken on the receptacle. Once we figured that out, plugged the hairdryer into the top receptacle, everything worked fine, and we were golden. Now, that was a teaching moment, right? So we educated them on the tabs and what they're for and all that jazz, and we all kicked ourselves because we didn't recognize the problem. So now fast forward Sunday, I get a phone call from a friend of mine. He says, hey Tom, he goes, I was changing a receptacle and I got current through his hand. He was lucky. He's lucky he didn't have the other hand touching something grounded and current go through his body, but it went through it hurt his hand pretty bad. So he says, I need you to come look at this circuit because I don't understand what happened. So I drove over to the house, and I probably have a picture. I drove over to the house, and yes, I do. I have a picture. Boom. So this was his receptacle. All right. Now, what was really interesting to me were these two conductors. There was a red wire and a black wire connected, and there is no ground, no equipment ground. Now, it's a metal box, and I think if you look back here, that's a metal sheathed conductor. But that was his receptacle, and I looked at I had a black, a red, and a neutral. And I don't know why, it dawned on me when I saw the black and the red. that we have the black one was connected to the top, the red one was connected to the bottom. Now the receptacle that was in here, now only one circuit was energized. No, he wasn't qualified. No, was not qualified, Joseph. Not at all. Not at all. But I'll tell you what he did. There was a lamp plugged into this receptacle. And I'll make an argument that the person who did the installation wasn't qualified either. So there was a lamp plugged into this receptacle. And I'll bet this happens all over the place. You go down to the breaker panel and you have a lamp plugged in and you turn a breaker off and the lamp shuts off. Plug the lamp into another receptacle and it works. Plug the lamp into that receptacle and it doesn't work, right? So you say, okay, well, this seems to work. Now, he doesn't know about the black and the red and the neutral, right? That's an indicator. Now, he was surprised there wasn't an equipment grounding conductor, a bare copper conductor. He's like, why isn't there a bare copper conductor in here? But, you know, he's not an electrician. He's a homeowner. Physical therapist, as a matter of fact. So he proceeded, his thought process was, well, I'm going to take the exact wires off and put the exact wires on. And he landed the red wire. And then when he grabbed the black wire, that's when he got nailed. And he didn't understand it because he turned the breaker off. The light was not energized. Now, it's not the neutral that he got hung up on, because I was thinking, when he first told me, I was thinking it was a switched, a three-way switch. But there's no three-way switch. It's a single light switch going to this receptacle. All right, so there's and you'll notice there's a red wire and a black wire. So I told him, I said, I will bet that if we go into the basement, there is another circuit breaker somewhere in that panel that's powering that black conductor. The top of the receptacle was not energized, and when I looked at what he took out, the top and the bottom on the hot side were disconnected. On the neutral, they weren't, which didn't make sense to me. I mean, if you're going to separate the top from the bottom, you've got to split this on both sides. So the top is one circuit, the bottom is a different circuit. That's not the case in his house. The only thing they they turn off on this they break is on the hot side. Now, I didn't open all of the other circuits, but my gut's telling me if this one was done this way, they're all that way. All they did was break the hot. They didn't break the neutral. So they don't have one circuit coming across the top and another circuit. So what I'm thinking, is that you have, this is basically what he's got, what I thought he had. You have a receptacle, right? And you have a receptacle. And then you have basically two breakers. One coming out to here and a neutral, right? And then the other coming off to here and a neutral. Now they're sharing a neutral, so let's do this. No, they're not sharing a neutral. Were there two whites in there? Hold on. No, they're sharing a neutral. Yep, they're sharing a neutral. So there and there. So that's basically what they're doing. there, and there. They got a hot, and they got the hot. So that is what he's got going on in his house. He opened one breaker. Neither of these breakers are side by side. There's no indication in the panel board that there's two circuits going to this receptacle. There's no handle tie, and that's required. And I don't know when the handle tie went in to the code, but there was no handle tie in on his circuit. College lab partner in logic circuit was an EE major and had the bright idea to tie all his logical zeros to OV. Open voltage. Goodbye, TTL. Yes, we're not born smart. We just get smarter as time. We're like we age to perfection, and hopefully we don't get we don't get killed in the end, right? You're right. Electrical time zone. You are right. The continuity of the neutral on the multi-wire branch circuit cannot depend on this device. So. Okay, Dawn. So 2008 code. So his house goes back to the 60s. So that's why. So that is why. So thanks, Dawn, for that little tidbit of information. We didn't get the handle ties until the 2008 National Electrical Code. Boy, that seems like it should have happened a lot sooner than that, in my opinion. But there was no awareness, and not until he pulled that receptacle out. Now, even if you were a knowledgeable person about this, it wouldn't be until you pulled that receptacle out, exposing those wires, that you would have realized that there are two circuits being fed. Then you got to go back and figure out what is the other source. Now, he was going to just say, let's kill the main. But, I had a meter, and we established an electrically safe work condition by making sure that we turned off the two separate breakers, which were not even near each other. One was like in the top right, and the other one was in the bottom left, something stupid. So they weren't even near each other, and there was no indication that they were related. In his home, in his living room, the tops of the receptacles were switched. The bottom of the receptacles were not switched. So anything he did not want to turn on and off, he had to put that into the right receptacle. I can't remember which one was not switched. I think the top was switched and the bottom was not switched. So like his television was plugged into the bottom. His lights are plugged into the top, and the light switch controls the top, and the bottoms stay on. I personally do not like that configuration. I am not a fan, not at all. Now, even if we had a handle tie, I don't know. But I guess it's legal. It's perfectly fine. So in any case, I'm going through things in my mind based upon what I was seeing. So that was how that rocked and rolled. Indeed, it's not a bad idea to check again for potential. Yes, knob and tube systems, dual fed, absolutely. All right, so then the question was, why? What was the reason you pulled the receptacle out in the first place? So the reason he started down that journey of changing the receptacles was because his cord would not stay in. Now, they had a discussion at the house between him and his wife, and his wife was like, well, we need to get a new lamp because the cord won't stay in the receptacle. And he's like, no, I think the receptacle is the problem because I plugged something else in there and it does the same thing. It just wants to fall out. So there's no tension. So he went and bought a new receptacle, turned the circuit breaker off, and the rest is history. Now, what that did was that sparked an idea in my head. Here's 2 times in a row that that this topic of splitting the 2 receptacles, separating them from each other, came up in the same week, in the same few days, basically. So I thought, you know what, that's a message to talk about receptacle maintenance. So, Robert from Omaha, you were the man, brother. So, let's talk about receptacle maintenance. Now, I have a few references for us. Receptacle maintenance. Rehearse with coach. I don't want to rehearse with a coach. I just want to move on. Ah, Robert. Yes. So why didn't they use the Woodhead tension tester? Because he's not an electrician. I don't even own one of those things. But I'm learning that I probably should to just test the receptacles. But that's going to be a point of discussion. And I'm glad you brought it up because I had to do some homework. I couldn't figure out who made one of those. That was a point of discussion on my NFPA 73 committee a while ago. So, but in any case, let's talk receptacle maintenance. Now, the first place I go to is NFPA 70B, but the scope of NFPA 70B does not cover dwelling units. It doesn't cover dwelling units. So if I go to, I'm going to just open up NFPA link for a second. If I go to NFPA 70B and we go to the scope of NFPA 70B, it says that covers the preventive maintenance of electrical, electronic, and communications systems and equipment. So that sounds good. The application. This standard applies to maintenance of electrical, electronic, and communication systems and equipment and is not intended to duplicate or supersede instructions provided by manufacturers. Systems and equipment covered are typically those installed in industrial plants, institution. Ooh. Okay, so this does it. This is interesting. I want you to see this. So I was originally thinking that NFPA 70B did not apply to the dwelling unit. I keep looking over here because my switcher, there it is. So here is the there we go. This standard applies to maintenance for electrical, electronic communications. Systems and equipment covered are typical of those installed in industrial plants, institutional and commercial buildings, and large multifamily complexes. It doesn't say that it only applies to that equipment that is in an industrial plant, institution, or commercial buildings, and large multifamily. It says it's typical of those. If I look at the scope, it says the standard covers the preventive maintenance of electrical, electronic, and communication systems and equipment. So, what do you think? Do you think that maybe this applies to a dwelling unit as well? I think. Let me take a look. If I look at the purpose, I got equivalency, I got units of measure. There's nothing in here that says this does not apply to a dwelling unit. It just says that the systems and equipment that are covered are typical of those installed. So a receptacle is equipment that you'll find in an industrial, an institution, a commercial building, and multifamily residential complexes. Oh, and it says consumer appliances and equipment intended primarily for use in the home are not covered. So a receptacle is not intended primarily for the use in a home. So this would be covered by 70B. I'm glad I read that. It says consumer appliances and equipment intended primarily for use in the home are not covered. So I would say 70B. 70B, it's for me. All right, so the first thing I did in Article 100, we defined what a receptacle outlet is. So what I had pictured previously is a receptacle outlet because it's an outlet where one or more receptacles are installed. And remember, this is what I've got here, 2 receptacles. 1, 2 receptacles. Okay, so this is a duplex. This is a multi-receptacle. This is 2 receptacles. Now, a receptacle is a contact device installed at the outlet for the connection of an attachment plug or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. A single receptacle is a single contact device with no other contact device on the same yoke or strap. This is my strap. This is my strap, right? That's my strap. This is the contact device. These are 2. So it says a multiple receptacle is 2 or more contact devices on the same yoke or strap. So this is 2 receptacles. This is a multi-receptacle. It's not a duplex. By definition, it's a multi. So next time you go to the store, you're going to wire a multi or try to find a multi. Chat. I'm looking at the chat. They used to break the tab on receptacles and run a switch leg to one side to switch lamps on the table and to have the other side energized for use in the room. Yes, Jody, that's exactly what they did in his house. Yep, and they still do that. I thought 210.70 does allow it. It is permitted, and it's not a bad thing. The only bad thing out of the entire picture is that there was no handle tie and there was no indication downstairs that you needed to turn 2 breakers off to that receptacle outlet for that circuit. Yes, it becomes too, well, no, technically, you know what? Oh man, you are just a stirrer, aren't you? If I break the tabs, I break the tabs that make the connection so well. If I break these 2 tabs, this is still a duplex. It's still a multi-receptacle. If I break the top and bottom tabs, I separate the top and the bottom together, but it still meets the definition. It still meets the definition where it says a multiple receptacle is 2 or more contact devices on the same yoke. It doesn't say that they have to be connected with each other electrically. It just says I have 2 on the same yoke or strap. By disconnecting or taking these 2 tabs off, I am not removing these from the same strap or yoke. And because they both share the neutral, it's a multi-wire branch circuit. Oh, check my email. Which email? Hold on. I got so many emails. I'm gonna, there it is. Oh, here we go. Look at this. And this is beautiful, Jody. Here you go. So one is a multi-wire branch circuit and the other is not. I'm just going to throw this up so you can see the entire thing. So we got, what do we have? We have a service panel board We have one is a multi-wire branch circuit and one is not a multi-wire branch circuit. Suitable means to be provided to simultaneously disconnect all. You know what? I've got to go back. I'm interested now in this, and I'm going to go back to his house with my meter. Because I want to measure. I'm not sure if they were off of two different. If it's 0 volts, I'm looking at this right here. If you have 0 volts between the two hots, but yet 120 to line to neutral, then it's not a multi-wire branch circuit. If you have 240 volts, now that's a red and a black. And so I assumed, in your drawing it's red and black, but in his picture, or in his application, he had a red conductor and a black conductor. I was making the assumption it was a shared neutral. But I'm not sure about that. I'm going to have to check that out. I've never seen a half-switched receptacle that was supplied from two different ungrounded conductors. All right, Jody. So that's the first picture. I am going to do this. I'm going to send this to Notability because we might draw on this. Import, done. And I'm going to look at your other image. Oh, I'm going to do this. I'm going to do a share file, and I'm going to go to import to Notability. I like Notability. I don't know if you guys and gals out there use it. Done. But I do. There it is. So that's the first one. This is the second one. Let me make it bigger. All right, Mr. Wages. So this was the other one that he sent. Yeah. So grasshopper. Yes. See this? On the one side, whoa. Hold on. Why is it doing that? On the one side over here, that tab is not broken. This tab is broken. You catch that? So on one side it's broken, and on the other side it is not broken. And what that does is that keeps your continuity of the neutral. Interesting. So, that's really interesting. This was the other image that we were just looking at. And what is and is not a multi-wire branch circuit. I do not agree with that top diagram sharing the neutral from two separate circuits on the same phase. Seems the neutral would need to be appropriately sized. Well, I don't disagree with you. But here's the thing. So here's the bottom line. Bottom line for this is that when you are going to do, like, replace the receptacles, all that jazz. You've got to know how to wire them up, how to recognize the infrastructure. Maintenance, if like what he was basically doing was a part of maintenance, right? He determined that it needed to be replaced. Then you can answer the question, does the National Electrical Code play a role? I mean, there's no permit required where we're at to pull a permit to replace a receptacle. So there would be no handle tie requirement. He doesn't have to go down into the panel board, move breakers around to get these two together. Is that a good idea to do that? It's probably a doggone good idea to do that. But it's not a requirement to get that done. Now, the other thing you got to think about are all of the different receptacles that you may be confronted with. Not only do you have to think about how they're wired in the back and what type of circuit that they're installed in from a safety perspective, but you've got to think about there are standard receptacles and you have GFCIs. You're going to have a GFCI type of device. You're going to have these devices that have both the receptacle and USB. You might have a USB only receptacle. I don't know if the tension on the USB. All right, and so in this is what's in the back of this type of a receptacle. This one here doesn't have the wires, but you have the terminations on the back, and you also have these where you push the conductor in, and then you tighten the jaws on the conductor. It's not a push and that's it. You have to push the conductor in and then tighten the screw, and the jaws just a different way to get in there. You've got the push to test buttons and the reset buttons. You've got to think about the electronics that's inside. You also have to think about the tension. We already talked about that. This device, this is a receptacle, but it's also a Type 3 surge protective device. Look at that. So not only do you have the receptacle to worry about, but you also have the fact that it's a surge protective device as well. So you're looking at the lights on this to say, is it functioning? Has the surge protective device given its life to protect whatever's plugged in on that circuit? Then you even have this type of receptacle, right? So we know these types of receptacles. We've seen these before, right? These are those you'll see like in a ceiling fan or whatnot. I know I got one of these at an IAEI meeting from a presenter who was doing the presentation, explaining how they function and work, and we've made some changes in the code. These meet the definition. These are a receptacle, but then they changed the defined term on what type of receptacle they are. You've got to think about torque. How about this one? This is not supposed to happen to a receptacle. All right. The plug is not supposed to melt into the receptacle. So this was cut off of a refrigerator that was in a garage, and it had been this way for years. And he could not unplug it. And when he looked at the bottom, this one here, because you think about all of this damaged stuff is hidden behind a faceplate. But he noticed that the receptacle prong right here was not looking very healthy. All right. So as when he finally got the faceplate off, killed the circuit and all that jazz, he realized that he had a little bit of a problem going on, which was probably a glowing connection because it wasn't torqued down correctly. So we have different types of receptacles, and we have to think about how they're wired, whether or not they're wired correctly. So that is, I'm going to get these out of my way because I know I'm going to hurt something. Now, this one here on the right with the light switch on the top, now that's a switch and a receptacle, both in the same outlet. That's still a receptacle outlet because it's a receptacle in an outlet. Okay, and David Engelhardt, you called it right. I'm going to talk about Chapter 24, wiring devices. Now, here's the other thing. Chapter 24 is on wiring devices. I need to call up Chapter 24. Chapter 24. The title of 24 is wiring devices. All right, so I just want to make sure the title, because I'm thinking about a receptacle. Now, what, as a professional, I know that a receptacle is a wiring device, but it's not in a defined term anywhere, right? I mean, how do I? In your guys' opinion, how do we get, and gals, I do have some gals watching this as well. So Dawn Gannier, Robert from Omaha. Where is the correlation between receptacle and wiring device? It's not in the definition. I go to NFPA 70. I'm just going to look at the definition in NFPA 70. Well, actually, I got the definition right here. It says a contact device, but it doesn't say a wiring device. I mean, what is, let me look at Webster. What is Webster? Webster definition of wiring device. Wiring device medium. All right, so what Merriam-Webster says is that that's wiring. Wiring device. Wiring device. Wiring diagram. There's no, let me see if it's one word. Wiring device. Search. No. So, how do we tie Chapter 24 with a receptacle? Fred B., how do you tie a receptacle to the wiring device? Where is that connection? I mean, I know it. And I agree with what your statement is. All receptacles are wiring devices. Not all wiring devices are receptacle. But where do we use the term wiring device? And I don't believe that it's a defined term anywhere in NFPA. Let me just do a search across all NFPA documents. I'm going to do wiring device. Wiring device. And I'm going to put that in quotes. I'm on NFPA link right now. Wiring device. Identification of wiring device terminals in 250. Wiring device without a separate outlet box. Cord connector. However, the wiring device industry also uses the term cord connector. This is wiring device. We don't have a definition of what a wiring device is. Let's go to NFPA 70B and see it. Is there any definition? There's no definition in 70B on what is a wiring device. What's the device? All right, so let's take a look at device. Good one, Mr. Let's look at device. What is a device? A, B, C, D. Device. Dead front, dental, device. Here is a device. Okay. A unit of an electrical system other than a conductor that carries or controls electric energy as its principal function. A unit of an electrical system other than a conductor that carries or controls electric energy as its principal function. So, okay. All right, David, I'm with you. Carries or controls electric energy as its principal function. So a receptacle would meet the definition of a device. And so they marry the two terms, wiring device. I guess a terminal block would be a wiring device. A light switch would be a wiring device. Would you agree those are three good examples of a wiring device? I could buy that. I could buy that. I'm buying what you're selling. So device, I'm just going to take a note. Device. Definition. In the NEC. I'm going to add that to my slides. So good catch. You guys are still hung up on the 200. 200.4a seems to indicate common neutral for multi-wire branch circuits. 200.4. Boy, you guys, oh, I love this stuff. You can't make this stuff up. 200.4 neutral conductors. 200.4a neutral conductors shall not be used for more than one branch circuit, for more than one multi-wire branch circuit, or for more than one set of ungrounded feeder conductors unless specifically permitted elsewhere in this code. And then there's multiple circuits where more than one neutral conductor, that's not what we have. We have one neutral. So, and then you have the multi-wire branch circuit, which is in Article 210. Device wiring. Are you saying that there's a device, comma, wiring? I don't think so. I don't think so. Device wiring. There's device heating, and there's disconnecting means. So it would be good, I think, to have the term wiring device defined, because we do define device, but we don't define wiring device. Key is for more than one. All right, so let's talk. 24.1, electrical maintenance requirements for the receptacles rated not more than 600 volts, receptacles, attachment plugs, pin and sleeve devices, heavy duty industrial. So the scope in 24.1 applies to only receptacles, attachment plugs, pin and sleeve devices, heavy duty type plugs, and cord connectors. Rated not more than 600 volts. So 24.1 doesn't cover terminal blocks, right? Because we said terminal block would meet the definition of a device. Its sole function is to distribute energy. I could argue, since wiring device is not a defined term, when you use wiring device, if I say a terminal block is a wiring device, then it'd be hard to prove me wrong because you don't have a definition to hang your hat on. You'd have to say, yeah, but I'm only applying to a receptacle or a pin and sleeve device or a heavy duty industrial plug, right? Now, remember, their frequency of maintenance is going to depend on the condition of the receptacle. I would say the condition of this receptacle right there, I'd say the condition of this puppy is ungood. Okay, that is a replace it discussion. You have, and remember, in these are the work that you could do. Visual inspections, you can clean. There's no lubrication on a wiring device, the receptacle type. Mechanical servicing. There's mechanical servicing that you can do and electrical testing that you can do, right? The condition assessment. Now, the condition, remember, there's a condition 1, 2, and 3. So you've got a condition 1, condition 2, and a condition 3 you've got to think about. You have the visual inspections, you have cleaning, there's no lubrication. So we've got to figure out how do I ascertain the condition of my receptacles. I do that by looking at 3 different criteria. If I go to chapter 9 now, I'm going back up into the book. I'm going to chapter 9, condition assessment. I've got to look at the physical condition. I've got to look at the criticality condition and the operating environment condition. So I would say criticality. If that receptacle is what my life support system is plugged into, in my opinion, that is a high priority. Now, maybe to Don Gannier and others out there, like, put that in the low priority list, but not this guy. Physical condition, that's easy. I mean, in my opinion, but you got to be careful. Just what you see here in front of the faceplate, all you're going to see are these 2 nubs. As we said on this one here, if you take a close look, this side is demonstrating some challenges, and the face of this is warped a little bit. So, but all of the other stuff, all of this back here, all of this stuff that looks so terrible is all hidden behind the faceplate. So in some cases, you're not going to be able to do a physical look unless you take that cover plate off. So you've got to assess the condition, and then you have the environment. Now, if you have the receptacle like down here, let's say that your receptacle is inside the house, but it's on an outside wall. That's a little different than a receptacle inside the house on an inside wall, because you've got conditioned temperature and air around it. If you have this receptacle on the outside, even though it's under a bubble cover and all of that, your environment for that receptacle is going to present opportunities for a degraded condition. So you've got to do a condition assessment of your receptacles. I think you could probably simply sit down and say, I'm going to make some assumptions. My outside receptacles, I'm going to have to look at them more often than my inside receptacles. Any receptacle on an outside wall probably should get looked at a little bit more frequently than a receptacle on an inside wall. Just because if you're on an outside wall, I know you've got insulation, but you've got temperature differences there. You never know what might happen, and we're not structural people, so boom. So in any case, I'm just looking at comments. Sort of points to a poor, ambiguous definition. I would tend to agree. I would tend to agree with you. All right, so once you ascertain the condition of maintenance, you're back at this table, and you know you've got to do a visual inspection, cleaning, lubrication, and electrical testing. Those are my pictures. All right. So I'm going to real quickly, because I'm coming up on 55 minutes. We had a good discussion. So now what I want to do is the chapter 24 is really, really short. And let's take a look at what's the visual inspections. You're going to check for worn, cracked, or distorted housings. Okay, so this one, even though this is distorted. This one here was distorted. Pins or contacts are burnt, bent, pitted, or missing in discoloration. This one here has some discoloration on the face. It's also burnt. Even though you may not see anything else, you do see some damage on this face. Securement method for flexible wiring is intact. Check for corrosion of housing, contacts, and pins. You're going to have to, I would say look at this rabbit ear up here. This little rabbit ear right up in here. This is rusty, but you're only going to see this if you take the plate off, the cover plate off of this receptacle. And if you have any gaskets, where might you have gaskets? If it's on an outdoor, etc., etc., right? And those are all 2A, which are offline standard tests. So you're going to establish an electrically safe work condition and do your visual inspection. Now, what kind of cleaning can you do? You can clean the current carrying parts. You can clean the exterior surface. But you've got to remember, you're not going to be spraying Windex on these things. You're not going to spray and say, oh, look, I'm not going for Windex. I don't want any germs, so I'm going to spray Clorox on it. No, you don't do that, right? You can wipe off, and I would say with a cloth or whatnot. I would not put water on these. I would not introduce other contaminants. Right? But follow manufacturer's instructions. There's no relubrication. Mechanical servicing. Let's look. What can you do? You can confirm secure mating of the plug and receptacle. Okay. I have a very secure mating of this plug and this receptacle. In fact, it's so secure, it will not, no matter what I do, I cannot separate those two. But that's not good. That's not a good indicator. And somebody, Robert, or who was it? Hold on. Someone said there's nothing in here about, does not seem to mention anything about testing the tension. Robert from Omaha. Look in table 24.3.4. Confirm the mating of the plug and the receptacle components. Now, it doesn't tell you how to do that. And there's not an informational note. There's no annex material that I can see associated with that table that would tell you that a tensioner would be something to look at. Now, you mentioned, let me just do this. Testing, what do we call it? Testing receptacle tension. I'm just going to Google it. I'm going to Google schmoogle. And there's a Granger. So there's a supply house. Crest Healthcare has one. Crest Healthcare. What's that? Look at this. Okay, here. This is sort of what you were talking about. Right here. This is Crest Healthcare. So this is a tensioner. You'll notice one pin is a ground pin and the other are your two prongs. That sort of gives you your, but now 70B is not giving me, 70B is not telling me what tension I should be looking for, right? That's an important part, but I would go back to the manufacturer on that one. Wiring devices shall be electrically tested in accordance with table 24.3.5. And this is confirmed grounding and bonding, which is a 2A. Offline test. And confirm proper polarity of contacts. It says you could do it as an optional. You can do it as a offline standard. You can do it as an offline or an online enhanced test. These are 1As and 2As. These are all enhanced. None of these are required. They're all enhanced tests, 1A and 2A. So all of your electrical tests are not optional. They are enhanced. If you see something else that doesn't look right, then you do these tests, the electrical test. So there's no required electrical test. The mechanical servicing test, they're offline, and this is confirming the mating of the plug. That's doing your tensioner. Confirm the cable gland nut is secure and retains cable, and confirm the tightness of all wiring terminations. So that gives you a little flavor for that. All right, and that's all there is in 70B. Now, 73 I thought had more in it, but 73, I can remember, NFPA 73 is the, the title of 73 is the standard for electrical inspections for existing dwelling units. So I'm going to type in receptacle, and in chapter 4, general requirements, general use switches and receptacles is section 4.10. And what we say there is that faceplates shall not be damaged or missing. Connection of conductors to termination points shall ensure tight connections without showing evidence of arcing or overheating. Switches and receptacles shall be fastened in place. The function of switches and receptacles should not be impaired by physical damage. Switches and receptacles should not be painted. We've seen that one. And it says that the wiring, it shall have correct wiring when tested. The tester shall provide location indications when the circuit conductors are not connected. So there's a lot more in the inspection. Those are all enhanced tests in 70B. Shall be replaced when found to be worn. To the extent that blade retention is adversely affected. So section 4.10.8 is sort of leading you into the discussion of the blade tension, right? So where's it at? Four point 4.10. Here we go. Receptacles shall be replaced when found to be worn to the extent that blade retention is adversely affected. Now, I know we had discussions during our code panel, during these meetings, on giving more information, like what is the tension you're looking for. We don't have any information there as well on what is the proper tension. When I looked at the indicator, it just seemed that there was it seems that there is values on the device itself, 24, 16, 10, 4, 24, 10, 16, 24. I'm not familiar with that product. So in any case, the tension and whether or not it can hold a receptacle is something that is of importance. And the grounded conductor of branch circuits shall not be switched unless both grounded and ungrounded conductors are simultaneously disconnected. So in any case, these are things you've got to think about. And then that's the standard receptacle. If it's a GFCI, you have, let me take a look in 70B. If it's a ground fault circuit interrupter, let's do a search for GFCI. That is in section 21, or chapter 21, which is ground fault circuit interrupters and GFCI. So you'll have to, for this device that's a GFCI device, you have to follow the chapter for wiring devices. Also, you've got to look at the GFCI requirements on how to properly test this. So you have a multi-function device that you've got to think about not just from a perspective of wiring devices, but also from a GFCI. And you also have USB, which is not covered in 70B. And quite frankly, I'm not sure what other than retention I would do on my USB. You'd want to make sure it's functional. But then you also have this type of device, which is a surge device. And you've got to make sure that the surge device is functioning as well. So what used to be something very simple has become pretty daggone complicated. You've got multiple functions in here that you've got to think about, not just one type of functional device. So, that's my story, and I'm sticking to it. Hopefully, hopefully you guys, I really appreciate the Alfred Suarez, Fred B. Tension tests are covered under UL. I'm going to have to look that one up. Lubricate your receptacles every day, especially if they're squeaking. Oh no. None good. Not good. Well, welding together is not covered. Thanks everybody for a great chat session. I appreciate all of the comments. I appreciate everybody who tuned in. And if you're watching this after the fact, remember we go live 12 o'clock Eastern. Pretty much anytime I can. It's pretty rare that I am posting recorded content for IAEI News Live. Thanks, Jody Wages, for shouting out and sending out the image. I appreciate that. Got to keep each other covered. So I appreciate you sharing the two images that we viewed. I want to make sure that we don't have anything else. Alrighty. Thank you very, very much. Thanks for all you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe. I will see you next week. And please stay healthy. The more you know about our trade, the harder it is to do it right. Amen, brother. So thanks, everybody. No, I can work more. Now you can work more. Excellent, brother. Go back to work and make sure it's safe. Remember, we want you to go home at the end of the day. Take care, stay safe, and please stay healthy.